So hello everyone. In this video lecture, we'll be learning about the next important topic, that is association rule mining. So first is like this belongs to the family of an unsupervised learning technique. So that helps us to test for the dependency of one data on another element. Okay, so say for example, you have a transaction which includes the collection of items that are purchased by the user. Okay, so while going for shopping. Okay, so if you would like to write an algorithm that helps us, the manager, to find out how likely a customer, if he's buying one item, how likely he can buy another item. So, what is the interesting relationship among the variables of the data set? So, for example, if a person who buys bread, so how likely he can buy jam? Okay, so for example, if a person is buying smartphone, so how he can buy the other items that are related to smartphone, like earphone. So this is about the relationship or the association. So where can we find the use case of the association rule mining? Okay, so in like rental cars or a hotel room. Okay, so if you would like to do an analysis based upon the products that are likely to be purchased by the customer. And secondly, in banking, okay, so like if a customer who have already taken the services like the investment service, car loan, okay, so how likely he can buy the other services that are related to the earlier one, okay, and similarly, like the insurance claim, okay, so like if there is a sudden surge of claim, okay, that gives an understanding, that is an expression of the fraudulent act. So similarly, like if you take the medical patient histories, okay, so how likely a patient can get into complications based upon the treatments what he has undergone. So these are all the use cases about this association rule mining. Okay, so now what we have to, like, for this algorithm that is called as a priori algorithm, we have certain variables that you have to understand. Okay, so it represents what are all the items that are available in the store. Okay, so you go to Amazon, what are all the products that could be available, like the books or any item what the user is interested in. Okay, and T is the collection of all the transaction. Okay, so it includes the transaction 1 till transaction N. So and Ti is the set of items. Okay, so for a particular transaction, what are all the subset of items that are purchased by the user? Okay, and each transaction will have an associated transaction ID. So this is about what are all the variables that are needed in the case of this a priori algorithm. So now what is the objective or the cause for the use of this a priori algorithm is to mine the frequent item set, is to extract the item set that are most frequently purchased. So to function or to work on extracting the frequent item set, so there is a rule. Okay, so this is the rule that is highlighted in green color. So the rule is a subset of an item set must also be frequent. Okay, so we say an item set is frequent. So say for example, I1, I2. So this is frequent provided it's subsets. Subsets is what? I1 separate, I2 separate. So those two also must be frequent. So this is about the rule that is used for mining the frequent item set. So this algorithm, it uses level-wise search. So level-wise search is like where k item set are used to explore k plus 1 item set. From one item set, we'll be generating 2 item set. From 2, we'll be generating 3. From 3, we'll be generating 4. So in this algorithm, the frequent subsets are extended one item at a time. So then groups of candidates are tested. Okay, so after generating all those different levels, from one item set we generate 2, from 2 we generate 3. So then the groups of items are tested against the data. So this is how we see that we are able to mine the frequent item set. So we build a candidate list of K item set. Okay, so and then we are able to get this frequent list of K item set. So for this, we use a strategy that is called as pruning. Okay, so we repeat until we are left over with an empty candidate K item set. So once we repeatedly generate the frequent item set from frequent to the candidate, so we just keep on repeating. We repeat until we are left over with an empty candidate or frequent of K item set. So let us consider, for example, this we will understand it with the help of an example data set. So let us consider this is the small data set that we are going to consider. This comprises of the transaction ID 100, 200, 300, 400, and 500. They are the transaction ID. So what are all the items that are purchased in every transaction? The first transaction, 1, 3, 4. Okay, these represents different item set. So it could be anything, book, pen, okay, so or iPod, whatever it is. Okay, so these are all the set of items that are purchased in the first transaction. So from this, we are generating candidate 1 item set. So what is candidate 1 item set? So you are given with an input of minimum support count. Okay, so if you want to find an item set to be frequent, provided the support count should be greater than or equal to the minimum support count. Okay, so say for example, the item set 1 separately, this is candidate 1 item set, and then 2, 3, 4, and 5. Okay, so now we'll have to find the support value for each and every item set. So one on like observing the data set. So 1, 1, 2, 3. Okay, so how many times it is appearing? The collection of transaction, it is appearing 3 times. And if we take 2, how many times it is appearing? 1, 2, and 3. So likewise, if we consider the item 3, how many times it is appearing? 1, 2, 3, and 4. So this is about your support count. So sometimes if they ask you in percentage, so this should be represented as 3 divided by the total number of transaction. So how many number of transactions are there? Okay, there are 5 transactions. So now we have given with the input as minimum support count. So what is the value? That is 2. So all those item set whose support is greater than or equal to the minimum support should be the part of the frequent 1 item set. So from the candidate 1 item set, we are generating the frequent 1 item set and all those. So if you consider 3, which is greater than 2, for this it is 3, which is great. So only for the item 4, so what is the support? The support is 1, which is less than the minimum support threshold. So, and all those are identified as the frequent 1 item set. So we are able to find the frequent 1 item set from the candidate 1 item set. And the next step is like what we need to explore is the candidate 2 item set. So candidate 2 item set is like, how do you take the combination of item set? So 2 item set is like 1, 2 is one combination, 1, 3, 1, 5, and similarly 2, 3, 2, 5, and 3, 5. So these are all called as what? The candidate 2 item set. So from initially candidate 1 item set. From candidate 1 item set, we have generated frequent 1 item set. From frequent 1 item set, we have generated what? Candidate 2 item set. So we are getting the combination 1, 2 is one combination, 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. So now you calculate what is the support value for 1, 2. So 1, 2 together, how many times it is appearing? It is appearing one time. So 1, 3 together, how many times it is appearing? So here it is appearing once. Okay, and here it is appearing once, and also here it is appearing once. So it is appearing for 3 times. So likewise, you will have to calculate the support value for the candidate 2 item set. So and again, for this, again, you will have to calculate we'll assume the minimum support value that is equal to 2. Okay, and all those items set whose support value is greater than or equal to the minimum support. Okay, and all these we are able to get. Okay, so and we compare the support value for the candidate 2 item set, and these are all the item set whose value is greater than the minimum support. So that becomes the part of the frequent 2 item set. Okay, so now once you have generated the frequent 2 item set, so you will have to apply the pruning rule. Okay, what is the rule that says that? We say an item set is frequent provided all its subsets must also be frequent. So if you consider 1, 3, okay, what are all the subsets for 1, 3 is 1 and 3. So if you consider 1, 5, okay, what are all the subsets of 1, 5? We see that 1 and 5. So both individually 1 and 5, 1, 3 must be frequent. So then we can say that if you say an item set is frequent, then we can conclude that all its subsets are frequent. Okay, that's only we are going to check. Okay, so from this, we see that what are all the subset? Okay, so subset is we have the value that is 1 separate, okay, 3 separate. Okay, so 1, what is the support? So 1 support count is 3. Okay, that is also frequent. And then 3, what is the support value for 3? 3, it is 4, that is also frequent. So except for every other item, we see that it is frequent. So we don't have 4 here. Okay, we don't have any 4. So all the subsets are found to be frequent. So we cannot perform any pruning at this stage. So now what we are going to do is like we are going to move to the next level. From the frequent 2 item set, we are going to generate the candidate 3 item set. So how we'll be generating? You take the combination of item set and combining 1, 3 with 1, 5. So what is the item set we'll be getting? We'll be getting 1, 3, 5. So similarly on combining, if you consider these two, 2, 3 and 5, what is the 3 candidate 3 items that we'll get? It is 2, 3 and 5. So similarly, if you have any other possibilities, if you consider the first one and the last one, on combining this, we will be getting 1, 3, 5, and already we have generated. Okay, so and if you consider these two, so these are all the possible combination. Okay, so what are all the possible combination is 1, 2, 3 and 1, 2, 5, 1, 3, 5 and 2, 3, 5. So already I have told that we say an item set is frequent provided all its subsets also must be in frequent. So what we are going to generate, we are going to see the subset. So subset for 1, 2 and 3 is 1, 2, 1, 3 and 2, 3. Okay. And subset for 1 to 5 is 1, 2, 1, 5, 2, 5. And the subset for 1, 3, 5 is 1, 3, 1, 5, 3, 5. And the subsets for 2, 3, 5 is 2, 3, 2, 5 and 3, 5. So whether all its subsets are frequent. So you will have to go back and check which table. You will have to refer to the frequent two item set table. So here we see that 1, 2, we see that it is not at all available. The support count for 1, 2, it is just 1. So it is infrequent. So 1, 3, no problem. So 1, 3, we have the support as 3, and 2, 3, we have the support as 2. So these are all no problem. Okay. So now coming on to this 1, 2, 5, so generate the subsets. It is 1, 2, 1, 5, and 2, 5. So we see that 1, 2 is which is infrequent. So similarly 1, 3, 5, generate the subsets, that is 1, 3, 1, 5, and 3, 5. So all these subsets are frequent. So on observing after generating the subsets, we see that the first two item set were 1, 2, it is support count is just only 1. So therefore, one of the item set, it becomes infrequent. So we are going to eliminate this first two candidate 3 item set. So what are all the things that are left over? We are left over with 1, 1, 3, 5, 2, 3, 5. So now what we are going to generate from the candidate 3 item set, we are able to get the frequent 3 item set, these two. Okay. So from this, what we are going to do is we are going to combine these two, and we are going to generate the 4 item set, candidate 4 item set. So what is the candidate 4 item set is? So I'm combining these two, 1, 3, 5, 2, 3, 5. So in combination, we get 1, 2, 3, 5. So 1, 2, 3, 5. What is the support count? Support count, it is just 1. This value is less than the minimum support, okay, which is equal to 2. So this becomes empty. Okay, so the minimum support value, what is given in this problem is 2. So at this time, from this candidate 4 item set, we are not able to generate the frequent 4 item set. This becomes empty. So once it becomes empty, we need to stop the process and we need to return the item set of the previous level. So what are all the item set of the previous level? It is the candidate 3 item set. Okay, so these, whatever we have got it, it is 1, 3, 5 and 2, 3, 5. Only these two are the frequent 2 item set. So from this, what we have to generate, whatever we have got till now, they are the frequent item set, what we have got it from the transaction. So now what we have to generate all non-empty subset for each frequent item set. So non-empty subsets is, if you consider the first item set, 1, 3, 5. So what are all the non-empty subset? It is 1, 3, 5. Okay, and combination is 1, 3, 1, 5 and 3, 5. So similarly, if you take the next item set 2, 3, 5, okay, so it is 2 separate, 3 separate, 5 separate, 2, 3, 2, 5 and 3, 5. Okay, so these are all about the non-empty subsets what we have generated. So I is 1, 3, 5 and S is what these are all the subset. Okay, so now what we are going to get is like for every non-empty subset, we are going to generate a rule. Okay, we are going to generate a rule of the form S derives I minus S. Okay, S is the subset, I is the item set. Okay, and the minimum confidence that we are going to assume it is 60%. Okay, how we are going to generate the rule that I'll be teaching you now. Okay, so for these are all the frequent item set and these are all the non-empty subsets that we have got it from the frequent item set. So what we are going to do is like we are going to apply the rule that is S derives I minus S. So what is the item set? What is I here? I is, this is your I. What are your subset? These are all your subset. each and every item set, this is your subset. Okay, so according to the rule, S is equal to I minus S. Okay, so let us consider the value for your item set is equal to 1 minus 3 and S, okay, S is equal to 1. Okay, so according to the rule, I is 1, comma 3, comma 5. Okay, and what is S? Yes, the first subset is 1. Okay, first subset is 1. So 1 derives 1 comma 3 comma 5 minus 1. So now this is a subtraction, right? So this one, you can strike it off. And the rule that you are getting is 1 derives 3 minus 5 because this 1 out of subtraction, these two got eliminated. We are left over with I derives 3 comma 5. So what is the rule? Okay, so that is how do you calculate the confidence? So confidence from the given rule, how you are getting it is support count of both left hand side and right hand side divided by the support value of left hand side. So support count of both left hand side, what is left hand side? We have 1. Okay, and what are all the values we have? The right hand side 3 comma 5. So support of 1 comma 3 comma 5 divided by support of left hand side. So how many times 135 it is appearing in the transaction? It is 2 times it is appearing in the transaction. Divided by support value of 1, how many times it is appearing? It is 3 times it is appearing. On calculation, we get the answer as 66.6. So likewise, you will have to consider the next rule. Next rule is 3 derives 135 minus 3. So on striking these 3 and this 3, so support value of both left hand side and right hand side. So what is there in the left hand side? 3. So support of 1 comma 3 comma 5 divided by support value of left hand side. So support of 135 it is 2. Support of 3 is 4. So the answer is 50%. So likewise, for every rule that is generated, you will have to calculate the value of confidence. Okay, so finally, what? Let your problem, they would have given a threshold for the confidence. For us, for example, the confidence is 60%. So all those rules whose confidence is greater than the 60% will be identified as the frequent rule. So this is the functionality of what? Association rule mining using a priori algorithm. Okay, so thank you for watching. We'll see the next lecture.